So for the assembly language programming, here we now have the instruction, which is the how do we construct a line by line code. So basically, it contains these parts, this label, this mnemonic, operands, and then a comment. So we can have up to 4 parts, but in reality, we can only use two. Okay, or we're only going to use two, which is the mnemonic and then the operands, because label and comment is just an optional thing. Okay, label is used for you to easily navigate or easily jump to that specific line if you're already using, let's say, a looping statement. And then comment is just, of course, a comment to say that maybe this line is for etc etc. So that depends on what you're going to put on that comment. Okay, basically what's important is the mnemonic and then the operands. Okay, and then we also have types. So the data movement or transfer instructions. We also have basic arithmetic instruction and then the sequence instruction and then the interrupt key or the int instruction. So discussion of this type within the discussion of the other type. So it will be discussed along with this discussion on what is this interrupt. So before that, let's proceed to data movement first. So the first thing that you guys need to know in assembly is the word move. Okay, I think it's also super obvious. Okay, it's just it doesn't have an E, but it moves data. Okay, this is used to move data among the different units of the machine. So it's a move instruction. So you can use small letter MOV or a capital letter MOV. So in assembly language, it's not because one key sensitive. Okay, so either of those will be fine. Again, we have here the label, and then here is the mnemonic key or the keyword or the format, and then we have here the destination and then the source. So this is the operands. So okay, so here is the destination, and then here is the source. That is one thing that you guys need to remember. Okay, so where will it go, and then where it is coming from. So it's like from right going to left or going to the middle. Okay, so we have some examples here: register to register, register to segment register. We have register to memory. It could be direct or indirect. We have immediate to register, immediate to memory, or it could be direct again or indirect. Okay, so of course, register to register. Let's just go back to your 3A real quick. So again, we have four major registers, which is the EAX, EBX, ECX, and then EPX. And then we have segment registers. We have the AX, BX, EX, CX, which is just a smaller size of those. And then we have another smaller size of this A, B, C, and D. We have the H, AH, everything is H, and then we have the L, and everything is L, EL, BL, CL, and then DL. So that's the pattern that you guys, uh, you guys can follow regarding with this smaller segment, also one segment register. Okay, you can also use this one, but uh, to avoid confusion, just memorize this one for now. If these variables is not enough, maybe you need more variables, then that's the only time that you can use the CS, DS, SS, and then ES, and then ID. For now, just be familiar with this one, since we already know that BH is 8-bit, BX is 16-bit, or EBX is 32-bit. So with that, we already know that the size of this one is something like that. And like here, we're not really sure, how small size this memory is. So you haven't confirmed if CS is only 8-bit or 16-bit. So it could be 8 or 16-bit. Okay. But anyway, so going back here, we have register to register. So what's happening here is whatever is the content of this ECX right here. Go back, zoom. Okay, so whatever is the content of ECX will go to EDX. So if you guys are going to take a look on the register, ECX will go to the EDX. Whatever is the content of the ECX will go to our EDX. So are you guys getting the idea? Are we clear so far regarding with this one?
Yes, sir.
Yes, sir.
Similar with the others, everything is from right going to the middle or going to the left side. So EX going to ES. So ES is small segment register. It is under right here. And we have a direct memory going to register from BH to byte field, BX to DL. Okay, so this is the let's see, a function keyword for a memory. Okay, this is a memory. Sorry, this is the register rather. Register to memory. I'm sorry, this is the memory itself. Okay, and then this is a register. So DH. So DH came from here, and then byte field is, I don't know, but it's the memory, and it's the direct memory, so it's the byte field. Anyway, we'll not be using byte field for now, so I'm not really sure where we can use this one, but in this module, there were no example on how to use a byte field. So uh, maybe Ma'am Suarez only focus from register to register and then registered segment, and we also have immediate, but for the memory. So Ma'am Suarez wasn't able to use this one, or wasn't able to give an example. Okay. But yeah, we can also do this one from register to memory. And then we have from memory, my apologies, mabaliktad ko na rin tuloy. From register also, okay, which is a BX, going to the memory, but it's indirect, which is now EDL. Okay. And then we have immediate. When we say immediate, so it is not a register, it is not a memory. Okay, so it's a variable, okay, or a constant. I'm sorry, it's not a variable also. Okay, so it is a constant value. Okay, so it could be hexadecimal, or it could be a decimal only, or it could be a character. Okay, so in here it's a 40H, so it's a hexadecimal going to a memory or to a register. Okay, so 40H going to CX, 25 going to byte field, and then 16H going to word field DX. Okay, so again, these are registers, small segment register. We also have this memory, which is the byte field. And when we say immediate, those are just hexadecimal characters or decimal characters, or just a simple uh, character. Let's say 25. It could be integer or decimal. Okay. So are we clear so far regarding with this one?
Sir.
Okay, so
Yes, sir.
since thank you. So we don't have enough time anymore, so we'll just continue this one on the part 2. So goodbye for now, and then see you guys later.
Bye, sir.
Goodbye. Okay, so hello. Let me just confirm if you guys are already on your computers. Just give me a thumbs up. Only one, two. What about the other two? Mr. Pulmano and Mr. Aliano. All right, great. So all of you are already here. Okay, so that's it for the register to register, register to segment, and then the other way around. So memory to register and then immediate to register. So we also have this one, which is the memory to register. So it's just the opposite of this one right here. So memory to register, it could be direct or indirect. We also have segment register to register. So it's the other way around of what we had in here. Okay. So the same byte field will go to CH, byte field BX will go to CX, DS will go to AX, and then BS will go to word field. Okay. So there is just one thing that you guys need to worry about when using this let's say special registers right here. You cannot move a size of 32-bit into a 16-bit. Of course, it will give you an error, okay, because you're like trying to fit a 32-bit into a 16-bit. So it's like putting a car into a motorcycle parking garage. Okay, so I think it's common sense that you guys cannot do that one. Okay, so of course, that will give you an error. But of course, you can do the other way around. So if it's small and then you're going to fit that one into a larger size, then it is possible because it can accommodate that small size. Okay, so I hope we're clear with that one. So the next one is Leia. So this Leia is specializing in offset. So this is similar with move. So it also move, let's see, a memory into a register. Let's see, a register to register, memory to a memory, or let's see, an immediate register to register. So they work pretty much the same. But this one is use initialize register with an offset in BX, DI, and then SI for indexing and addressing memory. Again, offset is the distance from this point up to this point. Okay, so we don't know the exact content, so we don't know what we're trying to let's say get, but we do know the distance, so we can use that one to get the data or to display the data. Okay, that is the main uh, functionality of this offset right here. So let's have an example. Leia EX and then EBX plus 8. So EBX plus 8 is the one that we're trying to pass or have and then move that one to EAX. So we don't know the data of EBX plus 8. Okay, what we know is the distance. So EBX plus 8 right here is the distance from this EAX right here. Okay, so if you guys are going to notice or check this one, initially, of course, EAX doesn't have a value. Okay, so it's 0, 0, 0, 0. But EBX has a value, of course, since, of course, you're transferring a data and then it must have a value. Then let's just say that the value of that one is this one, 00403 A40, and then plus 8. Okay, so we do know the distance, but this is, again, this is not the one that we are trying to transfer. Okay, so it is the distance from this EBX, that is the one we're trying to transfer to EAX. So you're going to add 8-bit. Okay, so that is why from here, from 40, it became, where is that one? This one actually. This 403A48. Okay, so this is the data that we are trying to get. So this is the content or the let's see, the address that we are trying to transfer to our EAX. Okay, so as a result, of course, this EAX now has a value of that 48. So just focus on the last value. From 40, it became 48. Why? That is because it has an offset of plus 8. Okay, so it ignored the first 8-bit. Okay, and then move after let's see, reading those 8 bits, which is now this 1 bit, 3A48. Okay, so really is able to follow so far on how we come up with this 4A. Okay, so let me ask someone again. Mr. Tanikala, what if EBX is plus 4? What would be the value of our EAX? Mr. Tanikala or Mr. Eliana? What if we have here EBX plus 8? What is the value of our EAX? Or Mr. Martinez or Mr. Pulmano? Anyone? None? Did you get? Okay, let's go back. If it's just EBX, okay, and then no plus 8, then basically the date of EX is as it is already this one, the 40. But if it's plus 4, then of course it will become 44. If it's plus 8, then it will become 48. If it's plus 12, then it will become 4C because C is for our 12. Again, A is 10, B is 11, and then C is 12. So did you guys get that one now? On why the value of EX, if it's plus 8, is 48. Hello? Are you guys still around? Are you guys even listening?
Yes, sir. Add lang pala.
Yeah, it's just the memory address. Okay, it's the distance from this EBX and then the one that you're trying to really get. Okay, so if there is no plus 8, it's similar with the move. Okay, you're just simply moving the value of EBX to EX. But since we're using Leia, we can use an offset. Okay, we can measure the distance from this EBX, and then plus 8. Okay, then you are now getting the value of this 48 moving to EX. Okay, so just do take note that this is the address, okay, that we are transferring, not the data itself. Okay, sinabi ko lang data kanina para medyo maintindihan nyo. Kasi from data to data tayo, di ba? From variable content to a variable content. But here, it's the address. Okay, in reality, I don't know if you guys can see the in reality, in contrast, if you guys are going to move, okay, which is the real content, the main content of that one, EVX plus 8 will make EEX equal to 0 times 0012C140, which is 1. Okay. So registers are these are the addresses, and then this is the real content, okay, the one that is stored in our memory, okay, which is this 0 times 0012C140. Okay. So note data movement or transfer instructions are very common in a assembly program since organizing and controlling the flow of data is one of the reasons why do we need to program a microcontroller. Okay. So we have some example of interrupts right here using a move instruction. So again, just like what I mentioned in our previous meetings, interrupt is could be an input or it could be an error that needs an immediate response. So in here, we have we're going to talk two interrupts right now. One is that requires to read a character, so it needs an input. Okay, that is one interrupt, which is 01H, and then another interrupt is 02H. So if we have read, okay, if it's asking this an input, then we also have a display, of course, which is the 02H. So 01 for read, 02 for the display. Okay, so in this example, two common DOS interrupts, which is the int21H were used. So you guys will see a complete format of this interrupt later on. But there is also one thing that you guys need to worry. So 01H is for read, right? So of course, upon reading, it will store that data into a register. Okay, it will not display it right away. Okay, so this will be saved always to AL. Just do take note on that one. Okay, so if you're going to as an input, let's see from 01H, this EH right here, this interrupt right here, it will be always saved or stored to our AL. So basically, if your program is asking input, then it will be always stored to our EL. So you guys cannot use EL anymore because it's already being acquired or being reserved by this read interrupt right here. Okay. Then after that, of course, it will be displayed. Okay. And then where is it being displayed? It is being displayed from the DL register. So EL and DL is now being reserved if you're going to use read and display interrupt. Okay. So this program accepts a character and display. So just do take note that this 01H will only accept one character only. So A just one, and then we'll display also one character for 02H. Okay. So before we proceed to the example, I just would like to show this one to you guys. We have a lot of kinds of interrupt in times 86. So we have 10H, 11H, 13, 15, 16, 19, 20, and then the 21H, okay, which is the 0, 1, and then 0, 2. So all of the discussions or explanations are already here, but we will not discuss this one anymore. So what we'll only discuss is the int 21H, 0, 1, AH1 or 0, 1, which is for read character, and the 0, 2, which is to write the character. So that's all for now for this module. So we will have more interrupts later on the finals. But for now, we just the read and display. Okay. So I hope we are clear with this one. If you guys have a question, just let me know. Okay, just ask the question right away. Okay. So we now have here an example wherein again that model small and then that stock 100H is a default setting or a fixed code. So you guys don't need to worry about this one anymore. Just copy as it is. And then that beta is an for now this one is empty. Okay, we didn't initialize or we didn't declare any variable. And then that code now is our flow of data or the algorithm or the operations that is being or that is happening here. Okay, so take a look on this one, move EX at data and then move DS EX. So this at data right here is this blank or empty segment. Okay, so since data is empty, then we're not actually passing anything. Okay, and then EX is empty. And then again, EX is being passed to DS. So basically DS is also empty. So don't you guys worry, this will not give you an error. Well, in fact, just use this one all the time, even though your that data is empty. Okay, so this will be a good habit to display or to read what is your that data. Okay, so sometimes you can in some cases you don't really need this one, so you can remove this one, but as a good practice, just always retain this one. Okay, so that you are always reading whatever is the content of your data, just in case that it has already a value. Okay, and then move AH 0, 1 again. This one now is 0, 1H. So we are storing that one to AH, but in reality, it's being stored to AL first before being stored to AH. Okay, and then EL, which is the same with AH again, is now being transferred to DL. Okay, and then if we have read, of course, we also have display command or code. So we have 0 to H, which is being transferred to AH. But of course, we cannot do that one by the way. So we have to do this one, move DL to AL. So whatever is the value of your AL must be moved to DL. Okay, since that is the registry that we're going to retrieve the data that is being stored, okay, or that is being displayed rather. So after this display character, then we can now end the see the loop or the program. So this is also an interrupt. This is a type of interrupt. This 4CH. This one means to end your program with this command. Okay. So end is another thing, but this 4CH is another interrupt to end your program. So this is an indicator that you are already ending your program. So basically, this is a fix. Oops. Okay, let me just get this one. So this is already fixed up to this point. So you guys don't need to change anything with this one. And this is also fixed. Okay, or we could say permanent. And then this one is just a function to read and to transfer the data from EL to DL because that is the one that is required. Okay, from here. EL that is being used in read and then DL that is being used in display. Okay. And then after doing that one, you're now going to display that DL, okay, on the page, which is the 0 to H. So read, store, and then display. And then this is just to end. Okay, and then these are the basic initialization. You are the initialization. Basic, I don't know what they call this one, basic structure, but yeah, it's just a fixed a code, so you guys don't need to worry about this one anymore. So you can just simply copy that one as it is, the same with this one. Okay, and then the rest of the middle depends on what you guys are trying to do. Okay, to be display a certain character, requires an input and display that input, and so on and so forth. So are we clear so far? Okay, so I really hope so that you guys are getting this one. So just in case you guys have a question, just let me know, okay? So let's now proceed to the next one. Again, this is a fixed code, so you guys don't need to worry about this one. And then in here, 01H is asking an input, so 01. And then in here we have, oh, wait a second. It would be better if we will try this one out. Pero na yata ako nagawa eh. What ba yun? Here, ELB, yeah, it is this one. So let's run this one. So again, it's asking an input from this 21H, this interrupt right here. So let's just put, let's say K. Okay. So basically, it already jumped to the display, which is here. Okay. Dito muna dapat, pero anyway, it already ended the program, but it already displayed the K. So this is the input, the first character, and then this is the display, the second character. And then another interrupt to end the program. Yeah, as you guys can see, program has returned control out of the operating system, meaning the program has already ended. Okay, so if you're going to rerun this one, so again, it's asking a data. Oops, here it's asking a data from the 01, let's say letter H. As soon as I click H, it happens very quickly, of course. So this is our input, and then this is our display. So are we here so far on what happened right here? So again, it just reads one character and display one character also. Okay. So we also have another one wherein the previous program displays the output key input on the same line with the input line. Okay, first character, second character, display it on the next line. Use DL0 EH interrupt. So this is another kind of interrupt, which is the buffer input. So DL is equal to 0 AH. So this one is using a line feed interrupt. Also use display string EL is equal to DL after execution. So basically what's happening here, yeah, then move next line. Okay, so this is already the code for this one. Okay, so I'm not really sure if it's talking about the next line, like we're going to have a notepad. Where is that notepad? Okay, so this is the first line, right? And clicking enter is another line, correct? So this is the first line, this is the second line, and this is the third line. Am I correct? Hello? Are you guys still around? Are you guys listening, or you guys are now eating? Wala natin nakikinig. End na natin yung meeting. Alright. Okay. So anyway, so supposedly it will go to the next line, which if that is what I understood according from this module. Okay, so it should proceed right here. But what's happening on this code, okay, let's run this one. So as soon as I click the first one, balikan natin. Let's go back from the start. Reload. Okay, so we have the same from the start. We have here 0, 1 each. So it's asking an input, which is this one, the first one. Oops, S. Okay, so that one was stored now to our BL. And then it is now asking another input, okay, which is this 0EH, which was supposed to be on the next line or down below. But it seems that that next line is just a next character, okay, beside this character right here, okay. So instead of a by row, I think it's by column, the one that is being talking here. Okay? Because it was emphasized here that the previous program, this one here, displays the output key input on the same line. So meaning same line right here. But in here, to display it on the next line, so I think it's now talking this one, which is the next line. Okay, but in this example, it's not actually on the next line. It's still on the same line. It's just I'm asking another input. So if I click, let's say K, then the display is still on the same line. It's just that we have a buffer right here, or a buffer input, okay, before it will display whatever is that the value of that AH right here. So are you guys getting the idea so far?
Yes,
So what I'm
sir.
trying to say is it's not on the next line. I think hindi ko lang kung magkamali lang si Ma'am Suarez. It's not on the next line, but still on the same line. But this one is just again asking another input. So it's like a separator only. We're going to run this one. Whatever is your first input, okay, will be the one that will be displayed right here on the third character after clicking another character on the middle, or let's see the buffer input. So SN and then S. Okay, let me just try this one out. Okay, so if you want to display the value of this DL, I think we have to because in here it's asking input and then it stored the value, but in here it's asking input, but it didn't save that value, okay, to somewhere else. So what we have to do is it using different DL will go to AL. Okay, I think that is the one that is not being saved. And then let's try to display that EL right here. 02H, but instead of AH, it's now AL. Okay, let's try this one out. S, and then another input is K. Just double the value of our AH. Give it a second. This is AH is already being used. And EL is also being used at the 0, 1 each right here. Ano pa ba iba? BL, CL. So that we can display both character, the first one and then the second one. SK. See pa rin? SKSS. So it seems that this DL is now being stored to our EL also. Okay, so basically they're using the same register, so we cannot retrieve the value of this one because the first one that occupy the value of AL is this AH right here. Okay, so going back here, whatever is the value of this 0, 1 each is being stored to EL, wherein it's already being used by this AH right here, unless ano ba bang iba? Unless it's not really 0 AH. I don't know anyway. So yeah, supposedly it will go to the next line, but it's on the same line. So the buffer input is just another input, which is this one. And then after clicking that one, will display whatever is the first input right here. So let me just bring this one back to its original form. There you go. So S, the first input, and then V is the buffer input. And then the last one is just a display of the first input. Okay. Anyway, that's it for this example right here for this supposedly going to the next line that it didn't go to the next line. Okay. Next output line. All right. So we have example 2 here, move instruction used in displaying ASCII characters. So in here we have the ASCII table, we have the decimal, the hex, and then the character that will be displayed. Okay, this well, I'm pretty sure that you guys are already familiar with this one. So 65 is always for the capital letter A, and then 90, what is the small letter E? 97 is for the small letter E, and then it's now incrementing. Okay, and then we also have the special characters right here, starting from maybe 33 only. Okay, 33 and then onwards up to 40 right here. Okay, because right here this now start of heading and so on and so forth. So these are non printable characters. Okay, so we have an example here. Again, we have this code right here which is fixed, but we don't have the code right here. Just move ex at data, move the ex, because our that data is empty anyway, so you can remove that one, or you can just simply put that one. So both of them will give you the same result. Okay, but for here, if go directly to move DL4, so we're passing the value 4 to our DL. So if it's not ending with H, okay, or B, it only means that this is an ASCII code, or a decimal rather. Okay, so that decimal will be converted into something else, which is, let's see, end of transmission. Okay, and we have of course we have read right here, and then we have a display right here, and then we also have another moving or reading of a data right here from 65 going to DL, or 65 is a decimal character, which is letter A, and it will be displayed, or it will be stored first to our DL and then will be displayed afterwards, which is the letter E. And then for CH is just to end our program. So let me just check if I already have the code for that one. I think it's this one. Okay, so initially it's 4 and then display, 65 which is A, and then display, and then to end the program. So what you guys will see right here, if it's a non-printable, second, may mali, may mali. I think hindi ko na-isip. Kasi special character na to, I think 70 plus kanina. Save, Emily, and then run. Wait a second. 4 and then 8. Why is it displaying naman? Let me just try to change this one. What about if it's 2? Two is a non-displayable character or non-printable. Four is an open parenthesis. Yesterday, when I was testing this one is actually a diamond. Okay. And that is a the symbol of a non-printable character. I don't know what happened, but it became an open parenthesis or an open bracket rather. What about if it's 7? Okay. It's a sound, which is a bell sound. Okay, it didn't display anything. But 4 is an open bracket right here. Okay. Anyway, so if it doesn't end with H, that only means that it's a decimal wherein it's getting a data or going to display a certain character. So if you want to display, let's say an open parenthesis, or let's say percentage 37, then we can also do that one, of course. Okay, a percentage and then 8. So 97 is for small letter A. So we now have a percentage and then 8. So are we clear with this example right here?
Yes, sir.
Okay. So 4 is I don't know if it's a bracket. Okay. But yeah, it's an open bracket. And then we have another example of move right here. How many minutes more do we have? Less than 1 minute. Okay, and then we still have. All right. So this is just another example wherein we're going to display a hello world. Okay. So in here, example to move instruction used in displaying a string. So EH is equal to 09H. So write string to standard output. So 09H is again another this one interrupt. Okay, wherein it will display a certain string or a message. Okay, so we have this example right here. Let me just try to get that one first. Hello world. Here. All right. So again, we have the default, the that model small, that's stack 100 each, and then that data. So in here we now have the initialization. So we have a variable message, and then DB is for defined byte, and then we have here the string, which is the hello world, and then later on we'll discuss what is this a $sign for, and then we have comma and then 10 and 13. So these are also additional functions wherein 10 is actually came from this ASCII code. 10 is a line feed, and then 13 is the carriage return. Okay, it's being discussed right here. So aside from the string, add 10 for the line feed and then add 13 for the carriage return for cursor to be on next line. Okay. However, when I was testing this one yesterday. I'm not really sure why it's not working, but supposedly this one is for the next line, okay, and this one is for the next cursor line. Okay, next line at the same time, and then our cursor will go to the next line also at the same time.
Sir, di kaya compatibility yung error niyan? Dahil DOSBox nung tinuro ni Ma'am Karen sa amin nun yan, sir.
Kaya nga eh. But I also tested this one in my DOS box yesterday. It gave me the same output. So napagana ko na yung DOS box ko kahapon. Pero ayun. So baka nga, hindi ko lang alam. Kung baka yung versions then maybe we have different versions of DOS box. But supposedly, 10 is for the next line, and then the cursor for the treating will be go to the next line. Okay. Well, anyway, let's try this one out for now in MU886. Ano mo ba to? Second take mo, Mr. Priester?
Yung lecture lang, sir.
Lecture. Okay. Bakit lecture pa? Di ba dapat lecture mas madali?
Baliktad, sir.
And there you go. It displays the hello world, but it doesn't have the cursor wherein maybe we could type, okay, and so on and so forth. And then what I did yesterday is I tried removing that one and running the program, and still it gave me the same result. So yeah, and then this dollar sign, I actually saw the Zoom meeting. This dollar sign is for an indicator to end that this string right here ended after this. Okay, this is string right here, because if without the dollar sign, it will give us random characters right here. Okay, it will consume the entire register, the register of this EX right here, which is 8-bit. Okay, but it gave me the same result. Hello world. I think that is the difference also, wherein it will give me an error. What is the error? Program terminated. Close that. Save, emulate, and then run. So int 21 h is equal to 09h address not found. So hindi niya yata nababasa yung this line of code right here, this message right here. Anyway, I think it really needs the dollar sign. Or let's try without the dollar sign. 10 and 13. Okay. So let's bring back the dollar sign. And it is now working perfectly. Okay. So in here, well, actually in the example of Ma'am Suarez, from the Zoom meeting that I have saw from this from her lecture, even though she doesn't have a dollar sign, it will still display the hello world, but it will give her a bunch of random characters right here. So he basically consumed the entire size of the AX, okay, or the AH rather, okay, because that is the one that's being displayed. So we can remove the 10 and 13 and it will still work perfectly, okay, and still give us the same result for the MU8086 emulator. I just don't know in DOSBox or TASM, okay. So yeah, and then one more thing. Again, this is not case sensitive, so we can have a message, a capital message right here, but we can still retrieve that one even though it's this is just a small letter. Okay, so we can also do this one, 2 capital letters, but of course it's not advisable. Okay, if you're using small letters, just use small letters for the entire code. If it's capital, just use capital letters for the entire code. But of course, it will still work, the same or perfectly, because assembly language is not case sensitive. Any questions so far, Mr. Polmano, for this one?
Wala, sir. Nakuha ko lang yung solution ko kung bakit puro random characters yung exam ko nun. Yung dollar sign pa.
Yeah, it's because of the dollar sign. Okay, so this one will automatically because it's a terminate string. Yun pala yung term dito, not an end. So this is the terminate string. So without $sign, processor will automatically consume the rest of the space, placing random characters. Okay. So we have another example here wherein you can now input a string. Let's close this one and input. Okay, because I tested this one, all of these yesterday, and then I'm having a lot of issues kasi hindi ko nakukuha yung tamang or yung expected output according from what Ma'am Suarez is talking in her Zoom meeting. Anyway, for this one, okay, so this is the part where it will not that one, 09H 01H offset message here. So this is the part where it will ask you a input string. So it is coming from this message right here. So enter a string, and then of course $sign is very, very important. And then it will, so 0AH is another this is the input buffer. Okay, just like what we had in here. So it will ask you another input. So display this one, and then the buffer wherein it will ask you an input for the new line, wherein new line can actually contain up to 80 byte, if I'm not mistaken. It's byte according from Ma'am Suarez, or 80 bit. Okay, well, any of those 80 bit is already big enough to store a value or a string right here. Let's say ASD, and then upon clicking enter, then it will display right here. Wait a second. New line is for the 1013. For the next line, I think at this point, this one worked now properly for the new line. Okay, so it is now displayed. So this is our input. It now displayed it on the next line. Okay, with the combination of this code and this code. So it went to another line and displayed the message itself, or the inputted string. So were you able to follow the sequence so far?
Yes, sir.
Wait a second. For CH, yeah. Miss out that one. And then yeah, I also tested this one yesterday, wherein we don't have the for CH. So this interrupt right here. So it gave me the same result. There you go. So nothing has changed. With or without this an indicator to end the program, because this end right here is already ending the program. This is just another way to end the program. Yeah, basically you can actually remove this one, but you can retain that one since it will give you the same result. So yeah, those are just the things that I've noticed when using MU886. Again, I'm not sure what will happen if we remove this one, and then you're going to code this one in a DOSBox or TASM. Okay, but for MU886, they are just the same. Okay, with or without this 4CH in there. So another thing is Y+2, because the first two line, or the first two register rather, is for, where is that one? Okay, the first 2 byte, here is the explanation. The first 2 byte of the memory location will handle the max length it can handle, and then the length of the string entry. Okay, so the first byte is the max length it can handle, and then the second register is the length of the string entered. So basically, we can only use 78 bytes. Okay, so it's not 80 bit. Okay, so it's actually 80 bytes, I think. Okay, so this is the correct one, byte. So byte is already a lot of characters that we can put in there. So yeah, that is why it's +2, because we can use the first and then the second register. Okay, so we have to do +2 to display the inputted message or inputted string. However, again, I did some experiment yesterday. +1 will still give me the same result, I guess, or it will move to the, will give you another tab right here. So instead of this tab right here, let's say this specific call this one position, okay, it will move, let's see, one tab, okay, or 1 2 3 4 5 6 7 8 spaces, okay, if it's +1. If it's let's say none at all, just displaying the string 1, let's try this one out. Okay, so that is the only time that it will not display anything, because I think you are now really getting the first two reserved memory, okay, which is maybe the location, not the location, the max length that it can handle, or the length of the string itself. Okay, so +1 will still work, but it's just after 8 spaces. There you go. After 8 spaces. And then +2 is the most correct one, I guess, since it will now display that one below, right below of this E right here. Okay. And then +3, that is the time that it will not be able to read properly the, the entire text. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But in here, it will only display 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I think it wasn't able to read this letter E anymore. Okay, and then onwards, of course, it will just keep on removing a specific line of characters, a specific count of characters rather. So in here, it wasn't able to read or display the A and then S if it's +4. So +2 is the most correct one, and then +2, another +2 is this A and then S right here. Okay, so are you guys getting the idea? So +2 or +1 is the one that is perfect in displaying by using an offset. So are we clear for this example?
Yes, sir. Clear.
Okay. So for the, I think this is already the last one. So in here, this is just another example. This will actually give us the same result. So it's using a Leia. Okay, again, move and Leia are just the same actually. So let's try this one out. New line db.good, move ex at data, dstx. Right here is the Leia si, and then string 1. Move each, 0 dx si into each. Move upside new line, and each string +2 first h. Yeah. So there you go. It will give us the same result. Okay. So move and Leia is pretty much the same. Okay, it's a different way. Okay, so in here you're going to use SI instead of the normal registers. So we have SI, DI, CI. What are those special? So na yun? Leia. Okay, we have here BX, BISI for indexing and address. Anyway, that's it for the last example. Similar result. It's just with the use of Leia. Okay, so here is now your task 3.2, which is the input output. So create a member registration form in assembly language. So allow user to enter the following information. So I would like you guys to figure out on how to, I can base it from here, from this last two example, okay, on how to come up with uh, this one, name, age, address, civil status, and so on and so forth. So it will ask multiple questions, or let's say, yeah, it's asking your name, it's asking your age, and so on and so forth. Okay. So just do this one using MU8086. Let's just stick with MU8086. Okay, since honestly, DOSBox and TASM is a little bit harder to use when it comes to assembly language. So I think that is the old way, and then MU886 is now the new way. Okay, however, of course, they will give you the same result. Okay, so are we clear for the task 3.2?
Yes, sir.